This question seems to be bringing together a bunch of different concepts. We have similar triangles, right? Triangle ABC is similar to triangle DEF, where A corresponds to D and C corresponds to F. Angle C and F are right angles. If tan of A is equal to radical 3 and DF is equal to 125, what is the length of DE? So I know that they're talking about two triangles, but I'm only going to draw one because when they say that they're similar, I know that they basically are the same, right? The sides are going to be different. But we're talking about trigonometry and things. I don't really want to think of sides as different, right? The whole point of trigonometry is that no matter how big or small that triangle is, the ratio of the sides is consistent because it's a right triangle and there's only so many combinations, right? So trigonometry is all about fractions because those fractions can get reduced no matter what the side lengths are, and they always reduce to the same thing. So let's draw our triangle here. Let's just give it one of these. Doesn't need to be pretty. And they say C and F are right angles. So C and F are going to be right there. Let's just do A here. D corresponds with that. So that means that B and E are right here. So DF is 125. So that's this, 125. And tan of A is going to be radical 3. What is the length of DE? So DE is right here. So that's what we're looking for. So SOHCAHTOA might come in handy here. SOHCAHTOA, that's the way we're supposed to remember the different trigonometric functions. So we're looking at TOA, tan. So tan of A is equal to the opposite over the adjacent. So that tan of A is going to be radical 3. And I know it doesn't look like a fraction, but remember, you can make any fraction, any number a fraction by putting it over 1. So that's what we're going to do, radical 3 over 1. So opposite, what is the opposite of A? I'm running out of space here, but the opposite is a cross. So that's going to be, how could I'm going to do it in terms of the D's. So that's going to be EF, and then adjacent is the 125. That's the DF there. So basically I have something I can solve for. I have that EF that I can solve for now by cross multiplying. This is a ratio. That's why they're called trigonometric ratios. So I can solve for that. And let's do it. So that's 125 root 3 is equal to EF. So that's right here, 125 root 3. Now a couple things can happen here. We could just, at this point, do Pythagorean theorem because we have two sides of a right triangle. And so be careful, we didn't want 125 root 3. There's definitely a reason that's an answer. That's to trick us. We want this. And this is why I've said this in many videos involving geometry. I don't like using X because X, when we see X equals, we assume the question is over, but they wanted something different. They wanted DE. So it's good to use the actual names of things. That way we're always kind of aware of what we're solving for and what we need to do. So I want this DE. I could do Pythagorean theorem. This is also a 30, 60, 90 triangle. Actually, I think I can paste it in here for you guys. Let's do it. Paste. There it is. Boom. Our reference chart. So you might remember that some of these numbers, that's what I'm trying to do, are familiar, right? We have a root 3. We have a kind of a regular number. So anytime you see like a root 3, or in the case of the 45, a root 2, you might want to be like, hey, wait a minute. Is this one of those special triangles? There might be a shortcut, right? So we could do Pythagorean theorem. It's going to take more work, but with Desmos, it won't be so bad. But if we recognize that it's one of these special triangles, we have a little bit of a shortcut because then we can see that we've got that proportion, right? This is the X side. This is the X root 3 side. So this must be the 2X side. So if X is 125, 2X is 250. And that's the answer. So I think that's a very important big picture idea with geometry, is that like certain numbers should kind of like trigger you to like make some sort of connections, right? Radical 3, radical 2, when we're dealing with triangles, that's not random, guys. It won't always be the case that it's one of those 30, 60, 90s, but here we had two sides that kind of fit that. So by definition, that has to be a 30, 60, 90 triangle. If we only had one, maybe it's different. But if we have two, then we're good to go. If I had seen a 30-degree angle or a 60-degree angle somewhere in here, that's another situation where I'd be like, it's probably that special triangle, because they don't just throw those numbers out there randomly. They're important numbers in trigonometry, in geometry. So get in the habit of having certain things kind of like trigger you to go to that reference chart or start to work on a certain formula or idea. That is how I get through these geometry questions so quickly, is I kind of like know exactly what I'm looking at because there's only so many things on the menu. And the reference chart is not complete, but it's a good way to think about the SAT. There's a menu and they're not going to ask you something that's off menu. So you kind of have to, you're limited to a certain set of topics and formulas, and that's it. Just kind of search your memory, search the reference chart. Something's going to stick and move you through the question.